So before I do the TS diagram, I've tried several different values for my P2, the exit of turbine 1, and I just want to make a little plot of that. So I'm going to highlight those cells and insert a XY plot. Go ahead and put dots on there, and I guess that's fine. We can smooth the data. It is a smooth line. Okay, so and I see right around 2000 kPa is a peak, and I just played around there a little bit, found out a little bit higher, right around 1900. So my efficiency in percent here is a function of pressure in kPa, and I can change the title to that, but for now, since it's right below the data, that'll work. Pressure 2 in kPa. Okay, so let's go on to doing a TS diagram. The easiest way to do that is probably to copy this. And it's going to be using data. Let me get this graph out of the way. It's going to be using data from the other spreadsheet when I do that, so I'm going to have to come back and adjust those values. But let me also grab this table and put that in here to see how I have that laid out. And that works. Make a little border for it. Okay, so then where are these values coming from? Just putting values in, that's fine. So these values, I could label the states, I guess. This is going to start with state 1. So the entropy is going to come from here, and the temperature will come from here. And make that a little bigger. And I guess since I have 3 digits there, there we go. All right, so this data that's used for this, if we look at where that's coming from, select data. I have SF that's coming from the TS diagram data, and SG that's coming from the TS diagram data, and then my process. So let's edit that. And that process is using the simple power plant example. So I want to change that to be this new one. And the second value is going to come from my new spreadsheet. Now, of course, you could create all this starting over, but it's a little easier just to edit these values. And so we can look at SF for, and those are coming from this TS diagram, so you don't need to change those, this page right here. All right, so now it's going to throw things off a little because I'm editing this. So then the second state would be the exit of turbine 1. So I want that entropy, same entropy, so equals that entropy, and the temperature I did calculate there, so this temperature, so equals, so there's my first two values there. The other values, I guess for now I can delete and just start entering those as I go. So the next thing would be the reheat. So that's going to be the entropy at the beginning or the end of the reheat process. So equals this entropy, and the temperature that corresponds to that would be the temperature of state 3, which is the specified temperature. So it goes back up. Then the entropy at the exit of the turbine, which is state 4, which is here. And the entropy, or the temperature rather, at state 4, which I did calculate. And then we noticed that that must have been a saturated value, or saturated liquid vapor mixture, because it's the same temperature as the condenser. I'm going to skip one point here, because if the state isn't saturated, then we need another little line that would say it stopped right here, that would come down to the saturation line, then across. So I'm going to leave a place for that break. I'll come back to that. So the next one would be the exit of the condenser, which is state 5. And I need the entropy for that and the temperature. So the entropy I'm going to have to find. So equals water. I'm going to specify, this is for state 5, so the pressure is known. The thing I want is SF, and I have to tell it where the pressure is. The pressure is, this is state 5, this pressure. And that will give me the entropy, and then the temperature equals water. Actually, I think I calculated this up above. State 5, I calculated the temperature, so I can use that one. Okay, and then it doesn't draw a line because I'm going to just copy these right now. So it will continue on. Now I'm going to come back and edit these. I'm going to put a little star here to remember. I need to modify that. All right, then we have the pump. The pump is going to have the same entropy and technically the same temperature, but I want it to show that it goes up a little bit even though the temperature shouldn't move. So I'm just going to take whatever temperature this was and add maybe 15 degrees. It doesn't look enough, so let's try 30 degrees. Alright, so I get a little rise for the pump, and then it's going to come out state 7 is going to be saturated, and I don't think I have the entropy, so I'm going to do the same thing I did up here. Copy this cell. So the other pump, and then I just need to make sure it's the right pressure. So this is the pressure that I'm using is pressure of 2, which I guess it's okay to use 6. I think I'm going to go ahead and just tag that to 2. And then this one was correct pressure. Okay, now this is the saturation temperature. I don't know if I calculated that for state 7. I guess I did, so we'll use that one. Okay, so that goes to the saturation line at the same pressure as this point, and then I'm going to have a pump again. So it's going to be the same entropy. The pressure will just give a little bump, even though technically it's stays almost the same place, but I'll use this temperature plus 30 degrees just so I can see the little rise. And then finally I'll go well, from state 8 to state 1, but there's a couple bends in that. So first I have to find the saturated liquid value. So at that pressure, I'm going to give the high side pressure, I want SF. And the pressure that I'm after is P1. I guess I could use P8 also. I guess doesn't matter. Use P8. So the high pressure, I want SF, and temperature I want is the saturation temperature, and I don't have that yet, so equals water. I know the pressure, I want the saturation temperature, and the pressure is this one. So 311 there, so now I'm at this point where there's a break. Then I'm going to go to same temperature. It's going to be a flat line, and it's going to be, this case, almost the same equation. I'll just copy this. But instead of SF, I want SG, and then I need to fix the pressure because it pulled it down. So that cuts across, and then I need one more line, which is just run it back to where I started. So this entropy and this temperature. And then I need to edit this to include those two values. Okay, so that's most of what I want. Guess I'll clean that up a little bit. Okay, so I've got all my values. If I were to let's say lower the low side pressure, or raise it up rather, so let's try like 500 kPa, then what I notice is it just cuts straight from here to the low side pressure, and it doesn't go down to the saturated vapor value. So that's the one that I put a little star on. So what I need to do is check the entropy of this, and if it's above the saturation entropy for that pressure, the saturated vapor entropy, then I need to add an extra point in there. Okay, what I did for this cell is I did a check to see what the entropy was. So I'm looking at the entropy of cell 34, which is this entropy right here, and I'm comparing it to SG at the same pressure. So, and if the entropy is greater than SG at that condenser pressure, or the turbine exit pressure, then I'm going to do this. And if it's not, then it's just going to be the same entropy as state 4. So what is this? It's adding an extra entropy in there. So what it's checking is this greater than this? If it is, then draw a line to there. If it isn't, then just draw a line to itself. And what that does is, when I'm outside the saturation curve, it draws this extra line. When I'm inside the saturation curve, it just draws a line to itself. And then I do the same thing for the temperature. So it's checking, is the temperature of this point greater than the saturation temperature? And if it is, then use the saturation temperature. If not, then just draw it to the same temperature as this point. So it's adjusting the temperature and the entropy so that I get this extra line when it's necessary. So now what we see, I can get rid of my little star here. So I've edited that. So now when I change this pressure back down, say to 100, then I have a short little segment that follows. But if I go inside, like when I was back at 10 kPa, then I don't get that extra little line. It just drops straight down into the saturation curve and across. So this is probably one of the reasons I made this part optional. It takes a bit of work to do this. If you want, you can go to the sample one and you'll see those same conditional statements here, this if statement. You might be able to copy that and then adjust, but make sure you understand what cell it's reading. It's looking here at state 4. When I copied this over to this one, it was linking it to like state 6. So I had to make sure it's checking the turbine 2 exit pressure and the states at those. I hope that helps. Can come back here, I guess. And what happens then, as you change properties, then your TS diagram updates. The one other thing that you could add is this extra line that shows the feed water heater. I didn't have a feed water heater in my first one, so you could have another process line that for the feed water heater, which would be you draw a line from this exit of the turbine, which would be state 2, and same temperature. And then this one, you'd have to do the same kind of conditional statement. If this point is outside the saturation curve, then you draw a line to it. So you might be able to copy these values. My computer's a little slow here, so let me pause this. I'll do the values and then show you what I did. Okay, so I've got my entropy and temperature for this point. My last value here is entropy and temperature for this point. So to represent that feed water process, I'm going to add another line or series to this. So add a new one, call it my open feed water heater process, and the X values will be my 3 entropies, and my Y values will be my 3 temperatures. And I probably don't want a smooth line, so click OK. I want that to be a straight line. And so there's my open feed water heater process. And how I did that, this second one was a conditional statement again. So it's checking, is this entropy higher than this entropy? So it's checking the same pressure and looking at SG at that pressure. And so it turns out that entropy is higher than this one, so it draws this line and then checks the temperature also. And then if it's not higher, then it won't draw that extra line. So if I lowered the temperature T1 down to where that first one didn't drop into the, or wasn't in the superheat, let's try that at like 400, then it wouldn't draw this extra little line. You can even try 350 here. Now I guess technically I need one more check. That's probably unusual that this won't go here. I've never considered that coming out of the first turbine. Then technically I should draw a line across to the superheat value and then go up. But if you don't anticipate this coming down to the saturation, you wouldn't have to worry about that. What I would have to do is between my second and third point here, just add that conditional statement again. Okay, so for what it's worth, I added that line in here. The only thing I changed is that now I'm seeing if it's less than, then draw the line instead of it greater than. So if this point is less than this, since we're going the other way now, draw this extra line. And if the temperature is, same thing, if the temperature is greater or less than the saturation temperature, then draw that extra line, and if not, then don't. So if I go back to, say, 500 degrees, then it draws it correctly. I hope that helps, and I enjoy creating the little dynamic TS diagram. Just kind of makes the spreadsheet much friendlier and nice to use, but if you don't want to do that, it's just optional for some extra credit on the project.